Okay, so let's have a continuation of what we were doing before we had a break in our recording. So I was saying that in simple harmonic motion, the acceleration of the body is directly proportional to the displacement. And the direction of acceleration, okay, is against the direction of displacement. So all that we are saying here is that when the direction of the displacement is in one direction, the direction of the acceleration is in the opposite direction. And these are the key features of simple harmonic motion. So I was trying to demonstrate this using the simple pendulum. Yes, if I did this is the simple pendulum. If I displace the body in one direction, okay, so the body's movement from the original position, this is the initial position, okay, when it is moved from a distance from the initial position to a final position, this distance from the final to the initial to the final is what we call as the displacement. Okay, so the body is displaced from here to this point. Now when the body is displaced, okay, we realize that when it is displaced in one direction, it will accelerate in the opposite direction. So the net force is applied in this direction, but when the body is left, the body speeds or accelerates in the opposite direction. So if I displace it in this direction, okay, and leave it, it will speed in the opposite direction. I displace it this way. When you leave it, it will accelerate in the opposite direction. Okay, but you realize that the magnitude of the displacement from the initial position to the final position is directly proportional to its speed. So when you displace it small, it will accelerate small in the opposite direction. If you displace it very little from the initial position and you leave it, look at the speed. Now if you displace it so wide, look at the speed in the opposite direction. If you displace it so wide in the opposite, look at the speeds. Okay, so we realize that the displacement y is directly proportional to the acceleration a. And in mathematics, when quantities are directly proportional, okay, a change and an increase in one will result in a corresponding increase in the other. A decrease in one will also result in a corresponding decrease in the other. Okay, so these two are the key features of SHM. Okay, it is the to and fro, the repeated to and fro motion. Yes, when I displace it, you see that the motion is repeated to and fro, back and forth. Okay, to this point from here, to this point from here, to this point from that point, repeated. Okay, but you realize that the acceleration of the body is directly proportional to its displacement. The wider it is displaced, the wider it accelerates in the opposite direction. You also realize that the direction of the displacement is always against the direction of the acceleration. So you displace it in this direction, it accelerates in the opposite direction. You displace it in this direction, it accelerates in the opposite direction. Okay, so you displace it here, you leave it to accelerate here. You displace it here, you leave it to accelerate here, and the motion is repetitive. Okay, and this is the key features or attributes of simple harmonic motion. So let's put the whole information together and define simple harmonic motion. So as I said earlier on, simple harmonic motion is a repetitive motion of a body So it is the repetitive motion. It is the repetitive motion of. Let's recoin it again. It is the repetitive to and fro. So that the to and fro or back and forth thing is so important. It's the repetitive to and fro motion. Whose acceleration is directly proportional to its displacement from the equilibrium position and is oppositely directed. Oppositely directed so just oppositely directed, or you qualify it better by saying opposite directed with reference to the direction of the displacement. Some people would also say that it is the repeated to and fro or back and forth motion of a body or a particle whose acceleration always directly proportional to its displacement and always directed to the fixed point. So in simple harmonic motion, we say that acceleration A directly proportional to the displacement y, and because it is it is the direction of the acceleration and then the displacement are always opposing, we say that acceleration is directly proportional to minus displacement. Meaning that when this is plus, this is minus. They are always opposite. If positive, positive, then it means they are always in one direction. If negative, negative, it means they are always in one direction. But when it is positive, negative, they are always opposing. So mathematically, we say that A is direct proportion minus y, and A is equal to minus a constant of proportionality y. And we use y because here we are looking at the displacement along the y-axis. If we are considering a displacement along the x-axis, then we say that A is equal to minus k on x. When we are looking at displacement of the particle along the x-axis, okay. So this is a simple, what we mean by simple harmonic motion. And note that all examples of oscillatory motion are examples of simple harmonic motion. So the motion of the simple pendulum, the motion of a bifilar suspension, the motion of a compound pendulum, the motion of a cantilever, the motion of a loaded or weighted spring, the motion of a loaded test tube in water, the motion of a liquid in a U tube, okay, are all examples of simple harmonic motion. In fact, they are all examples of oscillatory motion and also examples of simple harmonic motion. In our next video, we'll be looking at the relationship between circular motion and simple harmonic motion, and from there we'll also look at the equation, the displacement equation or function, the velocity function, and then the acceleration function in a body executing simple harmonic motion. Yes, thank you very much also much for staying tuned to the channel. Please, as I said earlier, please subscribe, share, and then bring your comments, feedback for a better improvement of the session. Okay, yes, thank you so much, and do not flip it. Continue watching, and goodbye. I'll meet you same time another day. Bye bye.